Hello class, welcome to the next segment in the week 9 material. And in this segment, we're going to be continuing our discussion on arrays and some other things that we can do with in the numpy module that comes with using the numpy module. So just to start off, similar setup that we've been using before. Again, we're making use of the numpy module and we're renaming that to again as NP. And wherever the computer finds NP, it knows we're talking about the numpy module, which again allows us to make use of arrays, which are a lot easier to work with in many respects than lists are. So again, much like before, we have two arrays that we declared here. And in this specific segment, we're going to talk about how we can actually do math with individual arrays. And we can also going to explore some other tidbits related to the NumPy module and arrays themselves. So to start off with, we have two arrays that we have defined up here. They are both two-dimensional, and we know they're two-dimensional, hence the two open brackets that appear at the very beginning here, and the two closed brackets that appear at the very end here. So that tells us it is, in fact, a two-dimensional array. So we have these two arrays that we're working with, and if we want to see what those arrays actually look like, then we can just simply have the computer print those out. So there are the two arrays that we're going to be working with. And whenever you're doing math between individual arrays, it's pretty much the same as you would doing math with between any two variables at all. You simply type one variable that's holding onto one array plus the other variable that's holding onto the other array, much like what we have here on line 15. Just this portion here that I have highlighted on the screen here, that's the actual process of adding the two arrays together. Now, unlike regular addition between two variables that each hold on to a single value, doing math between arrays actually comes with a couple of restrictions. One restriction is that the arrays themselves have to have the same number of dimensions. So in this case, that restriction is in fact honored here because we have a two-dimensional array in array 1 and we have a two-dimensional array in array 2. Now, another restriction that comes with doing math with arrays is the shape of the array. The shapes of the array must be the exact same. So in this case, we have what can be thought of as a 3x3 array and another 3x3 array. So since those are both 3x3 arrays, then we are able to do math between those two arrays very easily, just simply typing out one array plus the other. If you have, say, something like a 4x2 array and a 2x4 array, and you try doing math between those arrays, you're not going to be able to get any sort of intelligible result. In fact, you'll get an error message in the console if you try to add or subtract or multiply or divide any two arrays that don't have the same shape and also don't have the same number of dimensions. So if you at some point violate those two restrictions that I just mentioned, then the console will tell you as such with a lovely error message. So even though a 4x2 and a 2x4 array, they both have 8 entries, the shapes still have to be the same. It's sort of like taking a 4x2 matrix and a 2x4 matrix and trying to add them together. That isn't going to work so well from a mathematical standpoint, and the computer will not be able to make any sense of that either. But when adding two arrays together, each individual component is, in this case, we're adding two arrays, so each individual component is added together to get the result of the new component, which goes in the same exact position as the original two components. So simply put, 30 plus 2 will give us 32 in the top left-hand corner. 31 plus 3 will give us 34 in the next item over. 34 plus 5 will give us 39 in the next item over, and then so on and so forth. And the result that we get back will look something like this. So you can see 30 plus 32 gives us 32, the same position. 31 plus 3 gives us 34, the same position. 34 plus 5, 39, the same position. And then you see the process is repeated for each component in the two arrays. And just like adding two arrays together, we can also subtract two arrays. So here we can say take all the values in array 1 minus all the values in array 2. And just like before, each individual component will have the math performed on it. So here we get 30 minus 2 in this case will give us 28 in the top left-hand corner. 31 minus 3 will give us 28. 34 minus 5 will give us 29, and then so on and so forth for each component in each array. And you can see we do in fact get that exact result. 30 minus 2 gives us 28. 31 minus 3 gives us 28. 34 minus 5 gives us 29 in the top right-hand corner, and then so on and so forth for each component. Multiplication, done very much the same way, although I do want to make one point about multiplication here that is kind of important to keep in mind. So it's still very much the same process. Each individual component is multiplied together. So in this case, we would get 30 times 2 will be 60 in the top left-hand corner, 31 times 3 will be 93, 34 times 5 will be 170, 32 times 4 will be 128, and then so on and so forth for each individual or each corresponding component in both of the arrays. And you can see we get that exact result. 30 times 2 gives us 60, 31 times 3, 93, 34 times 5 gives us 170, and then so on and so forth. Now, I made a sort of analogy to matrices, and I want to make sure I'm perfectly clear on what exactly is going on here with the multiplication. Even though it might be customary to write two-dimensional data sets as a matrix of sorts, the multiplication that we're performing here, as you can see, is not matrix multiplication. If you have no idea what matrix multiplication is, great, you're not going to get confused by this, but if you do know what matrix multiplication is, just keep in mind that's not what the computer is doing here. Matrix multiplication is really complicated and convoluted process. This is very simple. This is just each component getting multiply together. Matrix multiplication is something way more complicated, but that's not what we're doing here. We're simply taking one component, multiplied the corresponding component to get the new result in the new array. And if we want to, we can divide the arrays by each other in any way we choose. So again, much like before, this will give us 30 divided by 2 will be 15, 31 divided by 3 will be 10.3 repeating, and then so on and so forth for each individual component. And you can see when we divide the arrays, we do in fact get that exact result. So again, we're not doing matrix multiplication. The math between arrays, they have to have the same number of dimensions, and they have to be the same shape. In this case, we're working with two 3x3 arrays, so all those restrictions are in fact met here. Now, another thing that I want to talk about has to do with the len function. Well, actually, let's get to the len function a little bit later. I forgot about this part of here. One thing I also want to talk about, which is something the numpy module has, is this function called the arange function. Notice this does not say the word arrange, which has two R's. This is in fact arange. Notice there's one R instead of two R's here. And one of the nice things about the arange function is it does pretty much the same thing as the range function, which we introduced in week 3 when we were talking about for loops. It does pretty much the same thing, but the end result that you get back is going to be an array. And one of the nice things about the arange function is you can put non-integers, as long as they're numbers, you can put any numbers in the function as you want. We demonstrated how the range function back in week 3, if you try to put decimals in there, the range function is going to refuse to work. But one of the nice things about the arange function is you can put numbers with decimals in here, but other than that, the two functions are pretty much the exact same. And one other difference, which I also mentioned, I'll go ahead and say it again. This gives you back an array of numbers, which is much like the arrays that we've already been working with in previous segments. And this also behaves very much like the range function. So we start at this number, go up to, but not including this number, counting up by this number each time. And we will in fact get an array back from that. And if we want to look at what that array looks like, we can just simply print out the value of x here. And you can see, I should probably get rid of this as well so that we don't have too many numbers on the screen. But yeah, here we can focus on just what x is. You can see one-dimensional array starting at 0, going up to, but not including 1.99, and counting up by this number each time we count up towards this number. Again, up to, but not including this number. And this kind of segues into what I was originally going to talk about earlier. I was kind of getting ahead of myself, but the len function works the same on arrays as it does with lists and strings. So again, the len function, all it does is it takes the item in question, which you put in the parentheses here, takes that item and counts how many entries are inside of that item. So in the case of a list, that's how many entries are in the list. In the case of a string, it's how many characters are in the string. And in the case of an array, it counts how many items are in that particular array. So since our array X here has it does in fact have 100 items in it, and if we want to verify that, you can see we print out the result we get back from the len function, which is 100, which tells us we do in fact have 100 items in the array X here. And if you want to go through the exercise of counting all these by hand, if you're really dedicated and want to do that, then you will in fact find there are 100 items inside of this array here. Now, the lint function gets a little bit more interesting when we try and apply that to, say, something that's two-dimensional. So if we go back to the two-dimensional arrays that we started with, again, we'll only focus on those. Let's actually focus on array 1 here since that's what we're working with. And just refresh your memory on what that looks like. There's array 1. And since we're working with something two-dimensional here, it may also be important to know how many rows and how many columns are inside of the array itself. And the way we can determine how many rows are inside of a specific array is we can use, first of all, we're going to use the len function, much like we did before, and we're also going to include the name of the array. But here, to actually pinpoint the number of rows, we're going to add some more stuff to what goes in the len function here. So we type the array that we're interested in, followed by a set of brackets. And remember how we discussed the first number in here is the row number, and this second number, or the second value, is the columns that we're interested in, or column that we're interested in. And if we do something like this, len, parentheses, name of array, bracket, and we put a colon in the row slot and the number 0 in the column slot, that will in fact tell us how many rows are contained within this specific array. And if you I'll leave this as an exercise to the viewer to work out how exactly this really works, how it does in fact give you the number of rows, but I'll just go ahead and tell you right now that just using the len function on the name of the array and then putting a colon in the row slot will in fact tell you how many rows are contained within that array. And then we can do a similar thing to get the number of columns. So here we can say, again, len function, name of array that we're interested in, except this time we put the colon in the column slot if we want to know how many columns are inside of that particular array. And if we want to, we can just simply print out what those two values are, print out the number of rows, print out the number of columns, and you can see this first print statement gives me 3, and we can see there are in fact 3 rows here. And then this second print statement gives me this 3, and we can see there are in fact 3 columns here. And if we want to know how many total items are contained within the array, then we can just simply take the number of rows, multiply it by the number of columns, and that'll tell us how many items are inside of the array overall. But that's going to do it for this final segment on arrays. There's a lot more to the NumPy module than what I'm covering, but uh, I think this is probably the most important stuff to know about the NumPy module. And in the next segment, we're going to shift gears and talk about something called the matplotlib module, which allows us to take some sort of data and plot it to a nice graph of sorts. So that'll be something we start introducing in the next segment. So with that, I will see you all there.